We're going to finish looking at rational functions today. Right? Generally, the two things we do with functions, we always look at how to draw them, and then we look at how to solve them. Okay? We've done the how do you draw them. Now we're going to look at how do you solve equations. We might still do graphing, but the focus now would be using the calculator to do it. No more sketching them by hand. So we're going to solve equations and inequalities that have rational expressions in them. Just to show you kind of an example of an equation we're going to be solving a little bit, that's a rational equation. Okay. It's got fractions, and the top and the bottom are both polynomials. All right, so let's start with this one. The first thing you're going to need to do this one, in case you don't remember it, is the formula that connects distance, speed, and time. That's distance equals rate times time. D is distance, R is rate, and T is time. So what's going to happen in this problem is Sue is going to be going on a trip. She's going to take two modes of transportation to get where she's going, and they give us a little bit of information about each mode. So it says Sue drove 30 miles, so by car, to a train station. From there, she got on a train. Altogether, she traveled 120 miles between driving in the car and riding in the train. The average speed of the train is 20 miles per hour faster than the car. That's all we know. We don't know the speed of either one. We just know on average the train is 20 faster than the car. They want us to find a formula to represent how much time it takes her to do this trip. So in other words, when I'm done, I want you to be able to tell me how fast the car was going. I plugged in the speed of the car, and the formula gives back to me the time it's going to take for her to do her whole trip. Okay, so how many modes of transportation is she doing in this trip? Or how many modes is she taking? Yeah? Two. So there are two different time values that need to be added together. The time that she spends in the car and the time she spends on the train. We have to add the two together to get the total time of the trip. So total time equals time she spends in the car plus the time she's on the train. And we'll just assume she instantly goes from being in the car to being on the train. There's no wait time between the two. It's instantaneous. If there was, we'd have to add that. Okay, now, we don't have any of the times directly, but we do have distances and we have rates. So what is time equal to, based on the formula I wrote up above?
Distance divided by rate.
Okay. So what we're going to do is start with the car. We're going to find the distance in the car. We're going to find the speed of the car. And when you divide the two, that's the time in the car. What's the distance that she travels in the car? 30. There's the distance. Now we need the speed. How do they tell us to represent the speed of the car?
X.
X. That, and I just put a box around, that's the time she spends in the car. Distance divided by speed. Okay. Let's do the same thing for the train. What's the distance she's on the train for?
9.
Right, it's 90. Because the trip was 120 in total, and 30 of it was on the car. Can someone else tell me what the speed of the train is? Yep.
X plus 20.
X plus 20. And there you go. So that whole thing is a formula for the time it's going to take her to complete her trip. And notice it comes out as a rational equation. Any questions on how we came up with that? So now if you tell me she's driving 40 miles an hour, I fill in 40 for X. the answer will automatically come out to the time it takes to travel 120 miles in her situation. So now let's see if we can find out some things about that graph. We're forgetting about the context that it's a car right now and you can't have negative numbers. You know, we'll get back to that. But for now, I just want you to think of this as just a pure equation. Nothing to do with the word problem. Okay. In order to do some of the things they're asking for here, you're going to need to combine these two fractions together. What do you need to make sure you have when you want to add two fractions together? Yep. Common denominator. And to find a common denominator, you multiply each denominator together, and that's the common denominator. So in this case, it's x times x plus 20. You could distribute that, or you could just leave it the way it is for now. What is the first fraction missing in the denominator to make it the common denominator?
X plus 20.
It's missing the x plus 20. So you're going to multiply top and bottom by x plus 20. What is the second fraction missing?
X.
It's missing the x. So you're going to multiply top and bottom by x. And now your denominator in both is going to be x plus 20 times x. And what do you get when you multiply this out, multiply that out, and add them together? That's going to be your new numerator. Yep.
It's going to be 20x. That's what wait. Oh, which one are we multiplying again?
We're doing that whole numerator
okay.
out.
So yeah, it would be 120x.
Yep,
plus
100.
60.
Perfect. 120x plus how much?
60.
600.
600.
60.
Misses 0.
So 30x plus 600 plus 90x. Now, some things you could leave it separate, but you do need them combined to be able to figure out some of the things I'm going to ask you about. Okay, so now let's just leave that there and start to answer some questions. Let's do the EBM first. Okay, what's the highest degree term in the top?
120x.
120x. What's the highest degree term in the bottom?
X squared.
X squared, yes. If it was all done out, it would be x squared. That gives me an EBM of 120 over x. Any question on that? Which part of the fraction has a larger degree, the top or the bottom? Yeah, the bottom. So this is like a problem from last week. Whenever the bottom is larger, you always have a horizontal asymptote. You're not going to get a slant or anything like that. Okay, so horizontal asymptote. Let x get bigger and bigger and tell me what's going to happen to 120 divided by x. What happens as x approaches infinity?
100 or
It gets very small, and what does it approach?
0.
It approaches 0. So the horizontal asymptote is 0. Remember that horizontal, if you want to think of the context of this problem, represents the time it takes to do the trip. So the time it can take will get lower as you drive faster, but it will never be 0. You can't have 0 amount of time to do this trip, but it will approach it the faster you go. Okay, so there's our horizontal. What else? EBM. Let's do the verticals. How many vertical asymptotes do we have here?
2.
2? Yeah, and what are they?
Negative 20 and 0.
Yeah, just make sure when you write them, you put them as equations with the correct letter. X equals 0 and negative 20. Okay, zeros. That's when we take the entire fraction and set it equal to 0 and solve it. What's the only way that a fraction can equal 0?
The top is
The
0.
top has to be 0. Okay. So let's plug in. Let's do that over here. 120x plus 600 equals 0. And hopefully the number that we find doesn't also make the bottom 0. So if you get 0 or negative 20 as the answer when you solve this, then that means there are no roots. But I think we're going to be okay. What does x equal in that case?
Negative 20.
Yep, negative 5. Which is perfectly fine. If you plug that into the bottom, you will not get 0. So that is the root. I'm not saying negative 5 miles per hour makes sense, but we're not thinking of it in terms of the word problem.
Go backwards there.
Yeah, so again, it doesn't make sense for the word problem, but it's what they asked for. So asymptote, zeros, EBM, and a sketch. Well, a complete graph means do it on the calculator. I would type in the second one because I think you have less parentheses because it's all combined together. 120x plus 600 divided by, and just to keep it even simpler, I'm going to do x squared plus 20x. If I don't do that, then I would have needed an extra set of parentheses so the calculator did the distributive property in the denominator. Okay, let's do zoom. Actually, let's do window. I know I got a vertical asymptote at negative 20, so I'm going to go past that. What else? X is the speed of the car. So let's go up to like 70 and see what the graph looks like. And I think everything else we could leave negative 10 and 10. I think that's okay. Since there's 2 vertical asymptotes, we should have 3 pieces to this graph. I think there is a third piece. You guys might not be able to see it, but I'm not zoomed far enough to the left. I just see like 1 pixel lit up on the screen. So let me go a little further to, actually I think I'm far enough to the left. I think it's further down. I think that was the problem. Yeah, there it is. So there's the leftmost piece, the middle, and the right piece. So as far as a window, I would say that window was okay. You could expand it out a little bit and you can see it a little better. I think that's a good window if you want to see all 3 pieces. Those are the values that I used. Any questions on finding what they asked for there? Okay. So now, it says that Sue has 2 hours to complete the trip. We have to find out how fast the car would be going. Not going to do it algebraically because we're going to spend a lot of time doing algebra in a little bit. I'm going to do it graphically because this is one of the only ones we are going to do graphically. First, let's think about the window. X is the speed. What's the slowest speed that you could have in this problem? Or the
0.
lowest? Yeah, you can't go below 0. And what's the lowest amount of value that would make sense for time?
0.
Yeah, you can't go negative time. So we'll go with 0. So what we're really focusing on in our graph now is what's just in quadrant 1. Okay. That was the rightmost piece. The other pieces were to the left of the y-axis. They don't really make sense, not in the context of the word problem. They don't matter. Okay. So there is the part of the graph we're looking at. The faster the car goes, the lower the amount of time gets for the trip. They want us to figure out when the speed of the car, if the trip takes exactly 2 hours. So how would I put a mark at 2 hours on that graph? I need to mark 2 hours somehow. Yep.
Y equals 2.
Yep, put a line at y equals 2. Okay, so now I know where 2 hours is. What would I do now? Yeah.
Find the intersection point.
Find the intersection point. And then once we find that x value is the speed of the car. I already know the y value. The y value of that intersection point is 2. It's it's going to be on the line y equals 2. But it's the x value that I want to know. So what would be the speed of the car? Yeah.
46.46 miles per hour.
46.46 miles per hour. Now, always be careful which one they're asking for. What if they asked for the train? If you accidentally wrote 46.46, it's like you did everything right, but then you didn't do one little thing at the end. What would be the speed of the train, if that's what they wanted to know? Yeah. Yeah, we would have to do the plus 20 on that. Good. So the train would be 66.46. But they didn't ask for the train. All right. Any question on that? Now, if I keep going to the right enough, will that blue curve hit the x-axis?
No.
No, it's an asymptote, right? It's a horizontal asymptote at y equals 0. It doesn't make sense that you would ever hit 0 because you can't travel somewhere in 0 amount of time. Unless you're listening to this 1,000 years in the future, and maybe we figured something out by now.
Time travel. There you go.
So
You can get there in a second.
we didn't solve it algebraically, so I just need to change that a little bit. I'm just going to say, if you multiply both sides, so when solving using algebra, if you multiply, which we are going to have to do this, if you multiply both sides of an expression by a variable, let's see if that makes sense now. When solving using algebra, if you multiply both sides of an expression by a variable, comma, this may result in an equation that's not equivalent to what you started with. So when we start to solve these algebraically, you're going to have to multiply both sides by a variable. When you do that, you can introduce extra answers in the problem that should not be there. There's no way with the method I'm showing you around that. So what we're going to have to do is check our answers and make sure that they work. In this case, work means that when you plug the answer back in, you do not divide by 0. If you solve and you get an answer that would cause you to divide by 0, we need to cross it out and label it as an extraneous solution. I might still ask you for the extraneous solution, but I would ask you to specifically tell me it is extraneous. So like I might have a drop down on the test, like you type the number in the box, and then next to it, it says, is this an extraneous solution? Yes or no. Click yes or no. So an extraneous solution is a new solution that came up that should not be there. Right? It came up because of something you did when you were solving the problem, not something you did wrong. It's just the method you used caused it to happen. So the only way to know that it doesn't work is to check your answer. Okay, here's an example. If you solve x minus 1 equals 0, what do you get? Yeah.
X equals 1.
You get x equals 1. Does everybody agree that that's the answer and there is no other answer to that problem? Okay. Now, let me multiply both sides by x. And watch what happens. X is a variable. Okay. So I get x squared minus x equals 0. I want to write the left-hand side factored. So think of it like this. Now, set each factor equal to 0 and solve it. If you set this factor equal to 0, what do you get?
X is 1.
You get x equals 1. You do get the original answer that should be there. But what if you set this factor equal to 0? What do you get?
X is 0.
You get x is 0. So the solution to this equation is x equals 1 and x equals 0. And I got that equation by doing exactly the same thing on both sides to my original. Does everybody agree I multiplied both sides by x correctly to get that? Okay. So I did the same thing on both sides. Now I got two different answers, 1 and 0. If I check them in the original problem, 1 works. How about if I plug in 0 in the original?
No.
It does not work. So by multiplying both sides by x, I created an extra answer in the problem that shouldn't be there. It's not that I did anything wrong. It's just that's what happens when you multiply by a variable. You can get an extraneous solution. Okay, so let's look at something with numbers first. Let's say that I had to solve this problem. Let's say 3 over 4 plus x over, let's say 5 equals 2x over 20. What makes that a little bit hard is just all the fractions. So if I wanted to solve this, the first thing I would do is I would try to eliminate my fractions by multiplying by the least common denominator. What's the least common denominator of 4, 5, and 20? Yeah?
20.
20. But I want to think of 20. Don't think of it as 20. Think of 20 as 4 times 5. Okay? It is 20, but I want you to think of it as 4 times 5. So let's multiply everything by 4 times 5. When I multiply this first one, I have 3 divided by 4 times 4 times 5. Something cancels there.
Good times 4.
The 4. I'm multiplying by 4, and then I'm dividing by 4. In the second one, it's x divided by 5 times 4 times 5. What's going to cancel here?
5s.
Yeah, divide by 5 times 5. And then here, I have 2x divided by 20 times 20. What's going to cancel there?
20.
20. 20, 20. Now I'm left with an equation that's a lot simpler than what I started with. 15 equals 4x, or no, 15 plus 4x. 15, yeah, 3 times 5 is 15 plus 4x equals 2x. Does anybody think that that's more complicated than what we started with in blue? No. Because now all we have to do is bring the 4x to the other side and then divide by -2, and we're done. But before, we had all these denominators, and that makes it more complicated. We're going to do exactly the same thing with this kind of problem. And notice how this number was a product of the 2 that came before it, that 2 denominators before it. That pattern is going to come up a lot. We should always check that we have that pattern. Because if we don't, then it gets more complicated. Like if I had a denominator of 4, a denominator of 5, and then a denominator of like 19 on the other side, well, now the common denominator isn't just 4 times 5 anymore. Now we got to deal with 19.
Because 19 is a prime number.
Yeah. But again, that's not going to happen in the problems that I give you. So we're going to solve this one. 2x over x minus 1 plus 1 over x minus 3 equals 2 divided by x squared minus 4x plus 3. First, let's just check and make sure that when you factor this denominator, let's see, it comes out to what's on the left side. How does x squared minus 4x plus 3 factor? Yeah.
X minus 1 and x minus 3.
Yeah, it does. It does factor as x minus 1, x minus 3. And I think for some people it's going to be easier to see that, but that's what it is. So now, let's do the same thing we just did up above. What is your least common denominator in this case. Yeah,
X minus 1 times x minus 3.
exactly. Just like it was the 4 times the 3 up above, now it's the x minus 1 times the x minus 3. So multiply that by x minus 1, x minus 3. Multiply the next one, x minus 1, x minus 3. And the right side, x minus 1, x minus 3. If you do this correctly, you are going to have all your fractions disappear at this step. Doesn't mean you might not still get a fraction in the final answer for a number, but at least the fractions are going to go away here. Okay, when we multiply out the first one, what's going to cancel? Yep,
Get x minus 1s.
times x minus 1 divided by x minus 1. How about the second one? Yep,
X minus 3.
the x minus 3 divided by it, x minus 3 times it. What's going to cancel out on the right side?
Bottom.
The whole thing, right? X minus 1, x minus 3, that is x minus 1, x minus 3. So what are we left with on the right side?
2x plus 1 is 2. Or on the right.
So on the right side,
On the right is 2.
just a 2. Now on the left,
is 2x plus 1.
we got some distributive we got to do. What's 2x times
Uh,
x minus 3?
2x squared minus 6x.
Okay, so that's the first part. 2x squared minus 6x. Now, the second part, when you distribute, this is where some people make a mistake. This is what you are distributing. In this case, it is a plus 1. But if that was a minus between the two, that minus would be distributed with the number in the top.
So that's
But in this case, it's plus
X
1.
minus 1.
So that's, yeah, it just stays as plus x minus 1. Okay, so now we have 2x squared
Minus 5x.
minus 5x. And then this is a quadratic, so what do we usually get quadratics equal to when we solve?
0.
Get it equal to 0.
So it's 3 plus.
Any question how we got that? All right, let's try to factor it. If we can't, we'll use quadratic formula. What's going to be my first term in each set of parentheses?
X.
That'll be one of them, yep.
And then 2x.
I need a 2x. Good. What about my signs?
Minus minus.
No, minus and plus.
Minus minus, when you multiply, would give you a plus
Okay,
right
minus
there.
plus, sorry.
Yep, we need one of each, and it does matter which one we put where. We could try that to start. If it doesn't work, we'll flip them. And then two numbers that multiply to give me 3.
1 and 3.
Yeah, 1 and 3. Okay, but when we check that, oh no, that is going to work. That gives us negative 6x plus 1x. And 1 times negative 3 is negative 3. Perfect. Yeah, that does work. Okay, when you set the first factor equal to 0 and solve, what do you get for x?
X is 1/2.
Negative 1.
Or negative 1/2.
Negative 1/2. And the second factor?
3.
3. Okay. All we have to do is check those to make sure that they do not cause us to divide by 0. Let's check 3. Look back. I think if you can't read the original problem, I can just move these out of the way.
3 does cause division by 0.
Yeah, where does 3 cause division by 0?
In the
One.
second part.
In the second part and
In the third.
in the third part on the right-hand side. So 3, it's not that we did anything wrong, it's just that's called an extraneous answer. We created that answer by multiplying both sides by something with a variable. In this case, x minus 1, x minus 3. Negative 1/2, that will work fine. Okay? The only thing you really have to check is if it would cause you to divide by 0. The only way the negative 1/2 wouldn't work is if you made a mistake. But I know the negative 1/2 is correct. But if you want to double check, you can still plug it in and see what you get. Okay. So there's really 3 things that can happen here. You can get 2 answers that work. You can get 1 answer that works, 1 that doesn't. or you can get two that don't work. It is possible it's a no solution problem. Okay. So I had another one that's pretty similar. Does anybody want to see this one? Want to do it? Yep, we can do it. Again, there's nothing new we're really going to learn here. It's just another example of the same thing. How does that well, in this case, it's not the right-hand side. They actually already set it equal to 0 for you. So that's going to save you a step. How does this third fraction factor? X times x plus 2, which is exactly the two denominators that come before it. So that's perfect. What am I going to multiply everything by here?
X times X plus 2.
X times x plus 2. Yep. X plus 2. X plus 2. X plus 2. And the right side is 0, so nothing's going to really happen. But you can write it if you want. And now cancel out what you can first. Joe, what's going to cancel out in the first fraction?
X.
Yep. Well, divide by x times by x. Okay. Ryan, what's going to cancel out in the second fraction?
X plus 2.
Divide by x plus 2, multiply by x plus 2. And Moises, the third fraction?
The whole denominator.
The whole thing. That's xx plus 2, xx plus 2. And the right side is just going to stay at 0. Okay. So remember what we have left. That's a distributive property. So we're going to get, I'm going to do it over here. X squared plus 2x minus 3x is how much?
Minus X.
Minus x. And negative 3 times positive 2?
Negative 6.
Negative 6. This one isn't distributive. It's just positive 3 times x.
Plus 3X.
Yeah, it's plus 3x. And plus, that's gone,
6.
just plus 6 equals
0.
0. I didn't write it over there. What's going to happen on the left-hand side there?
About my terms.
Combine like terms. Minus 6 plus 6 is gone. So we have x squared plus 2x equals 0.
Well, that's funny that I factored out.
Yeah, so let's see what happens. What do I do there?
You can factor that into X times X plus 2.
So we got x plus 2,
And both,
and that means the two answers from here are what?
both extraneous.
0 and negative 2. Can you plug 0 back in?
No.
No. Can you plug negative 2 back in?
No.
No. So both of these answers are extraneous. Which means this problem there is no solution.
That's like really funny how when it had the same thing happen 3 times.
Yep.
Yeah.
So, yeah.
X plus 2. X plus 2.
So that's the other thing that can happen. So you get 2 that work, 2 that don't work, or 1 works, 1 doesn't. You just have to check them and see. So if you got this far and you wrote these down on the test, but then in the next to it said, are they extraneous? And you said no. You said they both work, they're fine. I give you half credit because you got the answers right, but you didn't understand the idea of they don't work. That's an important part of the problem. Okay, so let's look at this one. It's going back to the train car problem, but it's worded a little differently. It's asking for, hi, come on in. All right, so it says, at what possible rates could Sue travel to ensure she completes the trip in less than 2.5 hours? What's worded a little bit differently about what they're asking? And this leads us into the last thing, yeah?
It's an inequality.
It's an inequality, right? So we got to be careful how we write our answer. It says, what is the time to complete the trip in less than 2.5 hours, not equal to 2.5. All right? So if I want to do it in less than 2.5 hours, I'm going to start out the same way. I'm going to type the formula in Y1, put my time I have to do the trip in Y2, and once they both graph, what am I going to do from there? Yep. Yeah.
Oh, you're gonna find the intersection point between the two.
Find the intersect. Okay, so now what I want you to do is interpret what our answer is going to be. She has to complete the trip in less than 2.5 hours. So what does that mean about the speed the car has to go at? Yeah?
Must be 34.88 or less. Or
It
greater.
is something with 34.88, but
Or
she can't drive
greater.
slower than that. She has to drive that speed or higher. I know it says to complete the trip in less than 2.5 hours, but that means you need to maintain a minimum amount of speed or faster to do that. Yes?
X is greater than 34.88.
Right. So the speed of the car is greater than 34.88 miles per hour. Okay. All right. Any question on that? So again, that kind of gets us into the last thing, which is an inequality. So most of these we're just going to do on the calculator like we just did. So when we solve graphically, remember we can have hidden behavior. Okay, did we look at that yesterday? That part that looked flat and it wasn't? People know what I'm talking about? Yeah, okay. So sometimes you might have to zoom in to see something. I think there's a USB on the back of the tower that's free, but I think there's everything there is probably full. So we could use a sign chart. We're not gonna do it that way though. We're gonna hold off on that method. We're gonna stick to pretty much just doing it on the calculator. So let's just try this one. So we literally are just graphing it, and then we're looking for like intersection points where they cross. When I type this in, do I need to do anything? Awesome, thank you so much. I appreciate it. Do I need to do anything special when I type it in Y1? Actually, I did it on this one as well.
Put it in brackets.
Yeah, you got to put in the brackets or parentheses. You need a grouping symbol because there's a lot going on there.
Hey, Mr. Hager,
Yeah.
question.
Yes.
Wouldn't the 2x2 and 2x2 cancel out?
No, because there's other terms that are in the top and the bottom. If it was exactly the same thing in the top and the bottom, then yes. But you have to look at that as the whole polynomial,
Oh,
not individual terms. Yeah.
it was just like way in a way. Oh, look great. Man.
Yeah, no, it's a good thing to notice. Plus 5x minus 3. And when we graph that, we're going to be looking for where that is under 1. Not equal to 1, under 1. Okay. Make sure you typed everything in right. I think we're okay. Start with zoom 6. I know we're going to have a horizontal asymptote because the degree in the top is equal to the degree in the bottom. Yep, clearly you can see that horizontal asymptote at 1. I didn't need to draw that red line, so, oh no, I did. I did want that. So we're looking for where we are under the number 1. Okay, first of all, is this top part ever under the number 1?
No.
No, so we can ignore everything having to do with that. The only thing I need to figure out is it looks like the left part is staying under 1 the whole time. Okay, I need to check that out a little bit closer. So let's go to our table and let's type in -20. Am I still under 1?
Yes.
Yeah. Let's do negative 200. Am I still under 1?
Yeah.
Okay, then I'm probably going to be under 1 the whole time.
For probably nothing. A long
So
time.
we are going to be under the number 1 from this point on the x-axis going to the left. It looks like that vertical asymptote is at 3. Let me check. Nope, it's not quite 3. Oh, negative 3. Sorry. Thank you. I could tell just by looking at it, it looks like it was on a nice spot. If it wasn't, then I would have to factor the numerator or denominator and figure it out that way. But when we start getting into a problem like this, I'm going to try to make the vertical asymptotes relatively easy to see. Okay. All right, so everything from negative 3 down gives us this left-hand piece of the graph, which is always under 1. So how do I write those x values? If it's everything from here down, I want it as an interval. Yep.
Wouldn't it be from negative infinity to negative 3?
Including or not including?
Not included.
Not including. Yep. Okay, so the left section's good. The middle, don't even have to worry about it. I'm not sure about this right section. Does it come up and cross? That's what I need to figure out. So if we go to 10, I'm at 1.02. Did I cross it?
Yes.
Okay, so then I did cross somewhere. So the next interval is only from the vertical asymptote up to wherever it crosses. Okay, so I'm just going to put here, just for the sake of time, the vertical asymptote. It might be, looks like it's pretty close to
0.5.
0.5. It is 0.5. I told you I'd make them easy to find. Okay, so it's from 0.5 up to, we need to figure out where we cross. So let's go blue, red, and I'm just going to put my guess where I think it might be. It's at 5. Okay, so from 0.5 up to 5.
Okay, not that bad.
That's the 2 sections of the graph here and 1, 2, 3, 4, right there. That's the only part of the graph that's under the red line. Other than that, it goes above the red line. Okay. So that's how you solve the inequality. There's not really a lot of algebra with that. So it's graphing, but it's not graphing by hand.
It's fun graphing. It's not like
It's,
pain.
it's not as hard on the calculator. But by hand, it can be a little hard to sketch sometimes. But
Yeah.
on the calculator, it does a lot for you, as long as you type it in the right way. Yeah. Okay, any question on that? Okay, this one, we're going to skip it. It would have been the same thing. Y1 for the left side, Y2 for the right, and then you're looking where it's above or equal. The difference is now you'd be allowed to use brackets. Okay? You can't use a bracket on a number that's an asymptote. But if this one was a less than or equal to, I could have put a bracket on the 5. Not on the negative 3, not on the 0.5, not on the infinity. But you could have put a bracket on the 5. That's the only thing that would be different here. And it only has one vertical asymptote at 2. This problem had 2 vertical asymptotes. So that one actually might be a little easier. Okay. Let me see, I can shorten that up a little bit. Let's make that just 1 through, it's really just 1 through 17. In case you're not sure. 1 through 17, just the odds. And then it's 20 to 22 all. And then 24, 28, 31, and 32. Okay, so we'll look at that homework tomorrow. And remember, I will be after school tomorrow for extra help. And we'll finish up section 4.4. And that'll be the last material on the test.